Okay, so this quick overview of our single slit experiment now. So single slit is exactly what it says, is it's just a single slit. So let's just have a draw at it. So again, we've got our single slit. So again, what you have now is we look at our film badge or look at our screen, it's just a single slit that light can get through, and then everything else is blacked out. So light can only get through that single slit there. So what we're saying is we've got our light, and what's going to happen is when it goes through, it's going to diffract. That's what we know. But in the single slit experiment, you have to imagine that every point in space is a virtual slit. So what we're saying actually is you have to imagine there's all these tiny little slits within it. And every point acts like its own point that the waves diffract from. So what happens then is on our screen, we still get our diffraction pattern. At the midpoint, we're always going to get that central maximum because it's traveled, all points have traveled the same distance. Remember that central maximum from our last video is that n equals 0. And then what we're going to do is we're going to get our bright fringes on either side. So our central maximum of our bright fringes on either side. However, the distant difference now is that the central maximum has a different width than the other. So when I was to draw the pattern on my screen here, so let's say we draw the pattern on that screen, when we draw our central maximum, it's going to be much wider than the outer ones. So again, remember if we're doing AQA, W equals YD over S, and if we're doing OCR, X equals YD over A. So I'm going to focus on the AQA, but if you're doing OCR, just know X is when every time I talk about W, and A is every time I talk about S. So what we're saying now is that the central maximum is going to be a much higher intensity than the minima on either side. Okay, so much higher intensity on the minima on either side. And hopefully what we can see is that represents W still, that fringe separation. So all these fringe spacings are still W, or X if you OCR. But the central maximum one, hope you can see, is double the width. So it's going to be 2 times W. It's going to be double the width of the other fringes. So again, what we're doing is a single slit. We're still going to see that diffraction pattern. The waves are still going to superpose. And anytime we see a central maximum, we know that's because there was constructive interference with the waves arriving exactly in phase of 360 degrees or 2 pi radons. And anytime we see a dark pattern between the two brights, we know that's because we had destructive interference where the waves arrive exactly out of phase, 180 degrees or pi radons. Okay. So what we're saying now is we're going to see how this equation would change if we change the wavelength. So let's say we used red light. So I know red light has a much longer wavelength. So if I increase the wavelength, what's going to happen is my W is going to increase. So let's say before that this size, so the black, let's say before the black for W represented 1 centimeter, right? So let's say that there was 1 centimeter. So that means my middle one was 2 centimeters. So now if I'm using my red light and I've increased the value of W, let's say W now represents 2 centimeters. So that means that all these W's now have to represent 2 centimeters, which means the middle one, which is double the width of the other ones, must be 4 centimeters. So if I draw that pattern at the top, if that before was 2 centimeters, now I need it to represent 4 centimeters. So you see the pattern of the top of it is going to be much wider. There's 2 centimeters, 3, 4, it's going to be much wider. And then so that one now represents my 4 centimeters, and then the other ones are going to be my 2 centimeters on either side, just reduced. So you can see when we change the wavelength, when we increase the wavelength, W increases. And we can see that that central maximum gets spread out further, and we can see that the pattern gets spread out further. So it affects all of them. Another thing we can think about is what if we manipulate the slit, okay? So here, S before was our double slit for slit separation. Now S is going to represent slit width. So now S represents our slit width. Or if we're doing A, if we're doing OCR. So we're saying now, what happens if I take my slit width and I decrease my slit width? If I decrease my slit width, I can see my value of W is going to drop. So my value of W is going to drop. So if I decrease my slit width, my value of W drops, okay? Which means the pattern is going to get much, much closer together, much more spaced in together. But if I decrease the slit width, what's also going to happen is I'm going to get more diffraction. So we know if there's a big gap, basically light always travels straight through it. We're going to get high intensity. But as we make that gap really small, close the wavelength, we know the light is going to diffract. It's going to spread out in all the different directions. So as I decrease that slit width, what's going to happen is I'm going to get more diffraction. If I get more diffraction, what that means is my rays are going to spread out more. If they spread out more, what that means is we're losing energy. Right? So if I spread something out more, if I spread the wave out more, it's going to be less intense. The energy spread out over a bigger area. So if I spread the energy over a bigger area, we're not going to have as big intensity. So yes, W is going to decrease, but we're also going to have a lower intensity. So let's say W now becomes 0.5 centimeters because we said we're going to drop W. Before it's 1 centimeter, now it's 0.5 centimeters. So that means the middle one, which is always double the width, is now going to be 1 centimeter. So before that was 2 centimeters, but now it's just going to be half of that, 1 centimeter, but the intensity is also dropped. So you see how my intensity now is lower. And the other ones are going to be 0.5 centimeters on either side. So 0.5 centimeters on either side. So you can see when we decreased the slit width, the pattern became much closer together, but also the intensity dropped.